Okay, so in this video, I'll say a little bit more about what a function is and how we use function notation, okay? And all I really want to accomplish is do 3 problems, okay? But I always think it's better to do a little bit of building up and a little bit of reviewing just to emphasize some things. Okay, so first, a function. What's a function? There's lots of ways I could describe what a function is, but I want to say right now that a function is a formula. It doesn't have to be a formula, but for now let's just say that it is, where we put one number in and we get exactly one number out. So it's like you could think an input and an output. I'll give you an example. So here's a function, say f of x. That kind of symbol right there, the f, the parentheses, the x, we read that f of x. That's called function notation. And this signifies that x is the variable in the function. It says 2 times x plus 1. And if I were to put a 5 there, that would mean that 5 is the input. What do you think it means if 5 is the input in that function? Where does the input go and how do you use it in that formula? Well, the input goes where the x is. The variable x in this formula right here signifies where any input would go. If 5 is the input, then you say 2 times 5 plus 1. What's that? That's 11. So if you put 5 in and you do the math, you get 11 back out. Okay? So that's how we use function notation. But if you study math and science and you go further along, then there may be lots of different ways of expressing the same idea. So I could say in the function f of x, f of 5 is 11. That would mean if you put 5 in, you get 11 out. I could also say if the x is 5, then the y is 11. That would be another way of saying the same thing. Okay. Another way is to express with something called an ordered pair, where I put parentheses 5, comma 11, and that means exactly the same thing as these two. It just means if x is 5 and y, then y is 11. In an ordered pair, we put our variables in alphabetical order, so x is 5 and y is 11. Okay, now let's talk now just about using function notation. Okay. So suppose I give you this function, f of x equals x squared minus 4x plus 11. You're probably going to be okay with it if I said, what is f of negative 7? You would say, well, okay, you take this formula, and wherever you see the x, the variable, you're going to replace it with negative 7, and it would look like this. Notice for emphasis, I put the negative 7 in red, okay? It's like I erased the x from this function and I put this desired input in its place. Okay? And then we just do the math, like negative 7 squared happens to be 49. Negative 4 times negative 7, that's positive 28, and plus 11, and then I combine all, that's 88. Okay? So our final answer would be that f of negative 7 is 88. In that formula, negative 7 goes in, 88 is what you get back out. So a number is probably not going to confuse you that much, but it might be that we need to put variables within functions, okay? Keep studying math and science and you'll see that the need arises to use something besides a number as an input to a function. But how about to do this, let's go ahead and start the same way, okay? So I'm going to take this and I'm going to put x minus 1 as my input, okay? So here's the function, right? X squared minus 4x plus 1. Would you agree? X squared minus 4x plus 11, sorry. What does the x represent in the function? It represents where the input would go. If you don't want to get all confused with the variables, you could write the function like this. You know, if you wanted to, you could say, I don't want to see it that way. The x is just this empty spot and whatever you're plugging into the function goes in that empty spot. So there it is, x squared minus 4x plus 11. Now in that empty spot, my input is going to be this entire expression, x minus 1. Okay? All right, so now this is what I need to simplify. This is kind of like being at this step, where I got to say, what is negative 7 squared? And what is negative, I got to do all that. So, okay, do you see everything that's involved? Do you see the original formula? And do you see that I took the input and put it in there? So people will be generally okay with this one, but then they'll get confused about this one because the input has x in it, but you put it in exactly the same way that you would put a number in. Okay, so that's what you do. What's x minus 1 squared? Well, what's negative 7 squared? What does it mean to square something? It means you multiply it by itself. Negative 7 times negative 7 is positive 49. So if I'm going to take x minus 1 and square it, that actually means to multiply x minus 1 by itself. So I'll be looking at that. And then how do you do negative 4 times x minus 1? How do you multiply the negative 4 times this entire thing? Well, it's like we're just saying everything in there gets multiplied by that number. So what's negative 4 times x? That's negative 4x. And what's negative 4 times negative 1? That would be positive 4. And then this 11, nothing's happening to that, so we're just going to carry it along. Okay. Now what about this? What's x minus 1 times itself? There's a procedure for multiplying one binomial times another. It's called FOIL multiplication. We do x times x. We do x times negative 1. We do negative 1 times x. And we do negative 1 times negative 1. There you go. So when we square this, we multiply it by itself, and we use FOIL multiplication to complete that procedure. Okay? All right, so let me finish carrying the rest of this stuff down. I'm gonna carry that down, carry that down, carry that down. Now, of all the stuff that you see here, can any of it be combined? Like I got x squared, there is no other term with a square in it. Like for example, if I said I got 4x squared plus 3x squared. Well, if you had 4x squares and you added 3 more of them, how many total would there be? There'd be 7x squared. These are called like terms. We imagine this as it's like saying that 4 apples plus 3 apples would be 7 apples. What's an x squared? Well, who knows, but if you take 4 of them and you add 3 more, there will be 7, okay? They are the same. They are like, so you can add them together. There's nothing like this one. There's no other x squared term. So that will just carry on into my answer. What about the x's? I got negative x and negative x and negative 4x. Those are like terms. Negative 1 and negative 1 and negative 4. That will be negative 6x. Okay, if I have those like terms, negative x and negative 4x. And then I've got 1 and 4 and 11, okay, and those are like terms, they're just numbers. You can add those together. So if I get 5 and 11, that's 16. Okay, so that's our final answer down there. That's the output, that's the result. Remember, this was the input. Okay, that's what it looks like to plug in that input. Worked all out, I get to this. Now I want to write my final answer as f of x minus 1 is x squared minus 6x plus 16. Okay, where just like this one, that's the input and this is the output. It just looks a little different when you're not strictly using a number, when your input contains a variable in it. All right, so let's try another one. Let's try this one, f of negative x. Okay, so where do I start? So I need to plug that input into this function, but I'll write it down that way. The input squared minus 4 times the input plus 11. So I'll go, just to be dramatic, I'll say it's, the formula is x squared minus 4x plus 11, okay? And here is what is getting plugged in. Here's the input. It's negative x. I used my red pen just to make it stand out that I've got the function, and in red is the input. Just like up here, and just like up here. Okay. Now it's all in the details from this point. I mean, how do you take negative x and square it? Well, I could tell you that that was just x squared. But it wouldn't be right if I didn't tell you why. Okay? So let's do a little reviewing. It's true that exponents deliver or distribute over multiplication. So if I have number a times number b all to the power n, see this parentheses, it doesn't just say that a gets the power or b gets the power, but they're held together by the parentheses. Well, exponents do distribute over multiplication. They don't distribute over addition or subtraction, though. Notice when I did this, I didn't say, well, that's x squared and that's 1. I didn't do that because exponents don't distribute over addition or subtraction. Here's how we handle that. But exponents do distribute over multiplication. So I get, okay, a to the n power times b to the n power. So I'm just saying, like, that's, as a matter of fact, one of the ways that exponents work. Okay? So, all right, so examples. So I had 7x squared to the second power. Well, everything in here would get that power. Like, I'd have to say the 7 gets squared and the x squared gets squared. So that's going to be 49 for 7 squared. X squared squared is going to be x to the 4th power, it turns out. If you take a number and raise it to a power and then a subsequent power, you multiply those powers together. That's another rule of exponents, which is something it's presumed you know when you take this class, but I don't mind reviewing it. If you need to review this kind of stuff, just ask. Now, about this, I was doing all this to explain why is negative x squared just x squared. Well, negative x squared, there's actually two numbers there. There's negative 1 and it's times x, okay? That's negative x. That negative, that dash is not just a dash, it's a number, it's a negative 1. So remember, exponents distribute over multiplication. So what's negative 1 squared? What's negative 1 times itself? It's 1. And what's x squared? It's x squared. So what's 1 times x squared? Well, we just say that that's x squared. There's no need to write the 1. All right, so that's how this one works out. Now, what is negative 4 times negative x? Well, you could see again that negative x right there is a negative 1, and negative 4 times negative 1, that's a positive 4. A negative times a negative is a positive, so that's just going to be 4x. And then this 11 gets carried down. All right. Now, anything else? Can any of that be added? Are there any like terms there? None of those terms are like. This is x squared. X squared is different than x. They can't be added together. And those are both different from just the number 11. So none of these terms are like and can be added together. Now, I want the answer to stand out from my work. Like here I was doing all this work and I said, there's my answer with function notation. Input, output. I want to write this one the same way. So f of negative x is x squared plus 4x plus 11. Okay. Written exactly the same way as I did with this first one.